Our solubility rule is like dissolves like, meaning that polar molecules are soluble in polar solvents, and of course water is the most common polar solvent. Nonpolar molecules are soluble in nonpolar solvents, and hexane is a common nonpolar solvent. The bottom of the slide we see two molecules, methanol and hexanol. One of the things that you are going to have to be able to do is distinguish between polar and nonpolar molecules. Both of these molecules are alcohols. Both of them have a hydroxyl group. However, methanol does dissolve in water, whereas hexanol does not. Now, hexanol has a long six-membered carbon chain that is nonpolar, and that sort of overpowers the intermolecular force of hexanol. In general, the carbon to oxygen ratio has to be 5:1 or smaller for an organic compound to be soluble in water. And hexanol has 6 carbons and 1 hydrogen, so that's a 6:1 ratio of carbon to oxygen, so it is not soluble. Methanol, on the other hand, is a 1:1 ratio of carbon to oxygen, and it is soluble in water. Now, if we look at some small polar versus nonpolar molecules, water, of course, is very polar, with a partial negative charge on the oxygen and partial positive on the 2 hydrogen. Methane, made of only carbon and hydrogen, is nonpolar. There is no separation of charge. The electrons are all equally shared in this molecule. Now, methanol has a methyl group as well as a hydroxyl group. So it has a non-polar region as well as a polar region. And again, if the non-polar region is too large compared to the nonpolar, if the non-polar region is too large compared to the polar, as is the case in hexanol, then the molecule will not be soluble in water. And this difference between polar and nonpolar can help us classify vitamins. There are 2 main categories of vitamins: water-soluble, which are polar, they dissolve in watery environments such as blood and urine, and fat-soluble that are stored in fat tissue such as adipose tissue. So if we look at these 2 examples here, at the top we have vitamin C, and it is water soluble. And we can tell by looking at the structure. For one thing, there's a heterocycle here with oxygen in it, which is very polar. And then there are 1, 2, 3, 4 hydroxyl groups as well as a ketone. So there are many hydroxyl and oxygens in this molecule, which means it will be polar and likely to be soluble in water, which it is. Below it, on the other hand, is vitamin A, which has this long hydrocarbon chain, a hydrocarbon ring. It does have one polar part on it, this hydroxyl group, but the rest of the molecule really overpowers that hydroxyl group because there are so many more carbon, way more than 5 carbons for that 1 oxygen. So vitamin A is nonpolar or hydrophobic, and it is fat soluble. It says on here fast soluble. That's a typo. It should be fat soluble. Now, water soluble vitamins are easily excreted through urine and from our body, whereas fat soluble vitamins can be stored in our tissue, and although it is uncommon, it is possible to retain toxic levels of fat soluble vitamins within the tissue. So you have to be careful when you take these fat-soluble vitamins not to take too many of them.